Welcome to this lecture course on Elements of Mechanical Engineering. My name is Atchuta Ramacharyulu and I am working as an assistant professor in the Department of Mechanical Engineering. In this lecture, we are in the second module where we are studying different types of boilers and different types of hydraulic machines. In the previous lectures, we have seen the different types of hydraulic turbines which comes under hydraulic machines. Now in this lecture, we are going to study the working of a reciprocating pump. So let us see. First of all, we have to understand the broad classification of any type of hydraulic machine. If there is a hydraulic machine, these hydraulic machines are broadly divided into two types. One is turbine and second one is pump. These are the two types of hydraulic machines that are available in the market or in the engineering society. So these two machines, they comes under hydraulic machines, like they will work with water in some manner and they can produce or they can utilize electricity in different forms. So the turbines and pumps are oppositely working machines when we compare both of them, where we will try to understand the difference in a very short time now. And here the turbine is a device which is used to produce electricity, whereas a pump is a device which is used to create head or pressure to the water. Okay, now we will try to understand this. If a turbine is there, turbine is a device which will convert the kinetic energy or pressure energy of the water. Like we can see in the previous lectures, we have discussed this already. Like the kinetic energy and pressure energy is converted into mechanical energy. Like the energy which is in the form of velocity or pressure can be directly converted by using this machine called a turbine. So this can be converted easily into mechanical energy, so that we will get a rotational energy or a reciprocating energy. So this kind of mechanical energies can be developed by using turbines. Now, when we take the example of a pump, here the pumps will act oppositely. I will draw here. So this is a pump, where this pump will use the mechanical energy. It will use the mechanical energy and it will produce kinetic energy or velocity. It will produce or it will increase the velocity of the water, or it can increase head and it can increase pressure. So from this we can understand the working of a turbine and a pump are exactly opposite to each other. So that is why this is a broad classification of hydraulic machines, which consists of two types of machines, that is turbine and a pump, where the turbine is a device which will convert the kinetic energy or pressure energy into mechanical energy, whereas pump is a device which will use the mechanical energy and it converts into pressure energy or kinetic energy. They will act in opposite. Okay. Now, as we have now understand that the working of these turbine and pumps are exactly opposite to each other, now we will try to understand the working of a reciprocating pump. So see here, before going into the actual working of a reciprocating pump, we will understand what is a pump, how exactly a pump works and how it is different from a turbine. So far we have seen the pump is a device which uses mechanical energy to produce kinetic energy or pressure energy that is related to water. So pump is a device which is used to increase the pressure of water. We know pump is a device. Simply in general terminology, pump can pump water. So it is a machine that can make the water move from one place to another place. Like we have pumps in our homes, we can use them for pumping the water that is present underground, and this underground water can be pumped into the overhead tank. Okay, so this is what any pump will do. In that case, our pumps which are used in domestic purpose, like in our homes, the pumps are used. There are two types. Previously, reciprocating pumps are used. Nowadays, centrifugal pumps are also very rampantly used. Apart from reciprocating and centrifugal pumps, we have submergible pumps. Very new kind of technology this is, where a very large tube is being inserted into the, so this pump is in the form of a, in the shape of a tube, and this will be inserted into the ground. Now by using this submergible pump, that means we can submerge the pump into the ground, where it will work to bring the water out of the ground, and this water can be used for any purpose. So pump is a device. In general terminology, it will move the water from one point to another point. But in scientific terminology or engineering terminology, a pump is a device which will create or which will convert mechanical energy into kinetic energy or pressure energy. This is not potential energy, it is pressure energy. Okay, PR. So the water, when the water is stored or when the water is present in a open lake, the lake is at a very stable point. So the water present in the lake is at a stable point. Now we will use some kind of pump in order to remove the water or move the water from lake to a field for agricultural purpose. If we want to move the water from a lake to a farmland, we have to use a pump. What this pump will do? This pump uses some kind of mechanical device which can produce mechanical energy. This mechanical energy is used to pump the water from the lake into the farmland. So in order to do this, the pump has to increase the pressure and velocity of the water that is being entered into the pump. Now see here, we have a lake here. This is a lake which contains water. We have a pump, and here we have a farmland. This is a farmland. Now my goal is to move the water from lake to the farmland by using a pump. Now what this pump will do is, it will take the water, it will increase or it will suck the water. That means the pressure inside the pump will be decreased, which will create say suction inside the pump, and this suction will make the water flow into the pump, and from there it will increase the velocity of the water again, and this water will be pumped out of the pump into a pipe, where I will connect a pipe so that the pipe will take the water into the farmland. So this work can be done by any human being manually, but it will take more time. Here we will use some kind of machinery like electric motor or a IC engine which is attached to the pump, and this will supply mechanical energy to the pump so that the pump will move the water from one place to another place. Okay, so the purpose of the working of pump is to convert the mechanical energy into kinetic energy or pressure energy. Now what happens is I will connect the pump with two pipes. One pipe is connected into the lake and another pipe is connected into the farm. So when the pump is switched on, that means I will supply some mechanical energy to the pump. So that mechanical energy that is in the form of rotation. So I will use a internal combustion engine or a electric motor attached to this pump. Now when I switch on this motor or an IC engine, it will rotate. It will also make the pump to rotate. When the pump is rotating, it will create a suction so that water will enter into the pump, and from there the pressure and the velocity of the water will increase, so that the water will forcefully enter into the pipe that is attached to the farmland, okay, where the water will be supplied to the farm. Now we have understand that the basic working of any pump. Now we are trying to see different types of pumps. How many types of pumps are there? The broad classification of pumps is of two types. One is reciprocating pump, which is the one we are going to see now, and the second one is centrifugal pump. Centrifugal pump. So these two types are the classification of any pump which comes under hydraulic machines. These two pumps have different purposes, they have different working manner, and also they have different applications. They are not same. We cannot compare these two because they have their own applications, like they will have their own uses. Depending on the particular application and the particular scenario, we have to select a particular pump and where it can perform better. Now in this slide, we are going to study the working of a reciprocating pump. Now we will try to understand the basic definition of a reciprocating pump, which is given in the scientific manner. Reciprocating pump is a positive displacement pump where certain volume of liquid is collected in enclosed volume, that is enclosed chamber, and is discharged using pressure to the required application. Okay, now this is the basic definition of a reciprocating pump. If you see carefully, the basic definition of a reciprocating pump states that it is a positive displacement pump. It is a positive displacement pump. That means the displacement or the movement through which that pump is moving, it is positive. The value is always taken as positive. And if we go to the deep meaning of this definition, we will collect a certain amount of liquid in a closed chamber, and again this closed chamber which is filled with liquid, this liquid will again be pumped to a place where we want to pump. Okay, so on the right side we can see a picture. This is a general reciprocating pump which is very rapidly used in all places. Like in India, it was very being used. Almost every home will have this kind of pump, and this pump is used to pump water into our homes for domestic purpose. And now we will try to understand the working of this pump. So this is very famous company. Like we have seen many reciprocating pumps of this same manufacturer. And see here, the reciprocating pump will have a cylinder here. Okay, this is a cylinder, and we have a crank wheel, and we have this is a air vessel which is used to control the flow. Okay, now when we go into the next coming slides, we will try to understand the actual working of this reciprocating pump. Now when we see the remaining part of this definition, reciprocating pumps are more suitable for low volume of flow at high pressures. When we want to move the water at a very small quantity with high pressure, then we can select reciprocating pumps. Previously we have said both centrifugal pump and reciprocating pump has their own abilities and their own properties where they can be selected and used for a particular purpose. Now, this reciprocating pump can be used for low volume of flows when we want to move very small amount of water. Okay, and this water can be moved at high pressures also. When we want to move the water at high pressures, then this kind of reciprocating pumps can be used. Anyway, centrifugal pumps are other devices which are based on a different concept where they can be used to produce large amount of water. They can move large quantity of water. Okay. Now another important thing that is missed here is it is not only used for low volumes and high pressures. This is also used for high heads. Now when we study the topic heads, we have studied this in turbines where head is defined as the level of water that is present in the reservoir when we study the turbine. Okay, now in this case, when we are studying pumps, everything works in opposite direction. Okay, in this case, we don't have any water that is stored behind the reservoir. We have to make the water to move to a certain head. Okay, like if this pump is used, this green color pump is used to pump the water to a overhead tank that is present at like 2 to 3 floors height. Okay, so this height is called as head in this manner. That means in the case of pumps, the height to which the pumping has to be done is called as head. Whereas in turbines, the head is defined as the height of water that is present in the reservoir. Whereas in pumps, it is the height of water, height to which the water has to be pumped. We have to move the water to this height. So that height can be taken as head. Okay. When we want to move the water to a high head, we have to go for reciprocating pump. Okay. Now, let us try to see the classification of different reciprocating pumps. So there are different types of pumps, that is single acting pump, double acting pump, where we will study in a bit how single acting pump will work. Based on that, we will try to understand the working of a double acting pump as well. And then we have, according to the number of cylinders present in the pump, we have three types, that is single cylinder, two cylinder, three cylinder. Very similar to IC engines, we have cylinders here. If there is more than one cylinder, we have to call it with the number. If two cylinders are there, it is called two-cylinder reciprocating engine. If there are three cylinders, we can call it as three-cylinder reciprocating pump. Sorry, I could have said engine. So this is a pump. So depending on the number of cylinders, we can call it with different names. Now, let us see different components of a reciprocating pump. So we can see in this picture, there are different components that are present. And first one is suction pipe. Now we'll try to understand the basic working here. So this is water. Okay, into this water we have dipped a pipe. This is a pipe which is dipped into the water. This water is called as sump, or it is called as sump well. The pipe which is dipped into the sump is called suction pipe. Simple. And at the end of the suction pipe, we have a valve. This is a valve where it is used to open and close. Okay, depending on the situation, it will open so that water will enter into the cylinder, and when it closes, water cannot enter. So this is a suction valve. And then delivery pipe. This is the delivery pipe. This is the delivery pipe which is attached to the other end of the cylinder, where water that is coming out of the cylinder can enter into this pipe and it will be discharged wherever it is required. So when we want to discharge water, we have to connect our pipe hose to this delivery pipe. So similar to the suction pipe, this delivery pipe also have a delivery valve. So this is a delivery valve where it opens and closes depending on the situation, so that the water can flow in or out. Okay. And then we have a cylinder. This central part, this is called cylinder. Okay. This is a cylindrical metallical part where it will have a piston arranged inside it. Okay. And the next part is nothing but the piston and piston rod. So this is piston, and we have a piston rod that is connected to its back end. And moreover, this piston rod is attached to the connecting rod. So this is the connecting rod. We have cylinder, piston rod, connecting rod, everything that is fixed, and this entire thing is very similar to an internal combustion engine. When you are studying mechanical engineering or aeronautical engineering, we will study the working of an internal combustion engine when we study the course thermodynamics. Okay. Now, in that case, the internal combustion engines will have the very similar kind of arrangement when we compare to this reciprocating pump. Here also we will have a cylinder, and we have piston rod, connecting rod, crank, etc. Everything is very similar, except we will try to pump the water by using this arrangement. In IC engines, we will produce mechanical energy by using the burning of the fuel inside the cylinder. Okay, we will produce rotating energy. Here we will give the rotation energy, which will increase the pressure or velocity of the water. Okay, here we have a connecting rod, crank and connecting rod. Crank is nothing but this mechanical element that is attached to the rotating wheel. Okay, this is called crank. And we have strainer. Strainer is nothing but it is a filter that is attached to the suction pipe, where it will filter the water that is entering into the cylinder. Okay, because when we want to remove the water from a very low, very deep wells or lakes, they will contain sand particles or stones, etc. When these particles enter into the cylinder of the reciprocating pump, they may cause damage to the internal parts. So that is why we will attach a strainer. This strainer will stop the foreign particles entering into the reciprocating pump except water. Okay, like when we want to remove the water from a pond or a lake, it may contain some aquatic animals like fishes and frogs. So these also has to be stopped at the strainer itself, so that they do not get into the cylinder and they may cause work failure, and as well as they may cause failure to the engines as well, the reciprocating pump as well. So strainer is the device which is attached to this bottom of the suction pipe, where it will stop the foreign particles entering into the reciprocating pump cylinder. And apart from this, we have another device, that is air. We have in the previous slide, this is, so this part is called, see here, this part is called air, this is called as air collector. Okay, so we'll see what is the working of that air collector particularly, or how it is used to produce uniform flow of discharge. Okay, so it is like a small chamber which is used to store water for a particular period of time, and whenever the cylinder is not producing enough amount of water, the water from this air collector will be sent into the cylinder, so that it will produce a uniform flow from the discharge, like uniform discharge can be formed. Now we will see the basic working of this reciprocating pump. See here, we have a cylinder piston arrangement which is attached to the crank of a rotating wheel. Now the function of this rotating wheel is that it will rotate only in rotational manner, maybe in clockwise or anti-clockwise. Any one direction is chosen, and it will rotate in that direction, where it will have some velocity, rotational velocity omega. Okay, and it will have some radius, r, and it will have some length which is equal to 2r, that is 2 times the radius, which is called as length of uh, the IDC and ODC. We'll try to understand all the terminology. What is IDC here? Inner dead center. ODC stands for outer dead center. IDC and ODC. Inner dead center, outer dead center. Now, what is inner dead center and outer dead center? When the piston is moving, if the piston reaches this left extreme point, that is called inner dead center. When the piston moving to the right side, like in this manner, it will reach this point. This is outer dead center. So, depending on the position of the piston, it is named as IDC, this is IDC, and this is ODC, inner dead center and outer dead center. So, we can compare the motion, or we can actually call whether the piston is moving from ODC to IDC or IDC to ODC, depending on the movement. Now, next thing is, now see here, when the crank is rotating, so we have applied some mechanical energy and it is rotating with a velocity omega. Rotational velocity is taken as omega. And when it is rotating in this motion, the piston will be moved. See here, if this is rotating in anti-clockwise direction, the piston will move from left side to right side, like this direction. It will move in this direction. The piston will move from here to here. Now what happens is, initially the cylinder is empty. When the piston is moving from left, that is inner dead center, to the outer dead center, this is IDC, this is ODC. Okay, from inner dead center to the outer dead center, what happens is, a suction is created inside the cylinder. So this is the cylinder which we are talking about. A suction is created in this cylinder, and due to this suction, here there is a suction valve. The suction valve will open. Okay, now we have to understand the working of this suction and delivery valves also. So the suction valve is a mechanical valve. It is also called as one-way valve. That means when there is a pressure applied on the bottom side, like if the water pushes on the bottom, the valve will open. But when the water touches or applies pressure on the top, it will not open to the bottom side. Okay, it will move only in upper direction. So it is a non-return valve or one-way valve. Okay, when the water is trying to move from sump to the cylinder, like the water is moving from bottom to top, the valve will open and it will allow the water to enter into the cylinder, because we have created a suction. Due to the creation of suction in the cylinder, the water will gently move into the cylinder. Now, when we have reached this position, that means ODC, when this crank point has reached to ODC, what happens? The piston is at the outer dead center. That means here, outer dead center. Now, after it moves to the point, after it rotates further, what happens? Again, the piston will be moving forward. That means from the right side to left side. That is from ODC to IDC. Now, what happens? The water will be pushed. Whatever the water that came into the cylinder will be pushed into the pipe. Here, what we have is, there are two valves here. One is suction valve and second one is delivery valve. Now, the water is here. Water is present inside the cylinder. Now, when we push the water, the suction valve will not open because it is a non-return valve. It will not allow water to flow back into the suction pipe. Okay. Now what happens is, here we have a delivery valve which will be operated now. That means it will open to upward direction and it will allow the water to flow into the delivery pipe. Okay, from delivery pipe we can collect the water and we can send the water wherever it is required. So this will be done repeatedly, like 200 to 300 cycles per minute. That means we will generally tell 100 RPM reciprocating pump. That means it will rotate 100 times per minute. The crank will rotate 100 times per minute. For one revolution, we will have a movement from IDC to ODC and again from ODC to IDC. That means one entire cycle will happen in 1 minute. Okay, in one revolution, the entire cycle will happen. That means suction into the cylinder and delivery into the delivery pipe. So this will happen in one rotation of the crank wheel. Now this process will repeatedly be done at 100 times per every minute. That means 100 RPM. Okay, if the wheel rotates at 100 times per minute, we can produce 100 pulses of water that is coming out of this delivery pipe. Okay, now this is the basic working of any reciprocating pump. Now we will try to understand the working, or we will try to calculate the discharge. Okay, when we try to calculate the discharge, we have to name some terminology that is related to this reciprocating pump. That is, we will denote the discharge with Q. Q is the discharge, that is the amount of water that is coming out of the reciprocating pump, and A is the cross-sectional area of the cylinder. Here we have a cylinder. This cross-sectional area is also taken into the calculation. And again, L is the stroke length. We have seen here, this is L. L is equal to 2 times the radius of the crank. Where L is the stroke length, it is also calculated. And N is the speed of the pump in RPM. So, in how much speed the crank wheel is rotating, this is taken as N value. Now, if you want to calculate the discharge is given by Q is equal to A, L, N. A stands for cross-sectional area of the cylinder, L stands for stroke length, and N stands for RPM over 60. So this will give you the discharge of water that is coming out of the reciprocating pump. Now, we have seen in the classification, this is for a single cylinder. This is the formula for single cylinder reciprocating pump. What if there are, this is single acting reciprocating pump. What if there is a double acting reciprocating pump? Here we have a double acting reciprocating pump where we can see this picture here. So this is a double acting reciprocating pump where we will have 2 suction pipes and 2 delivery pipes. In the previous one we have seen this is a suction pipe and this is a delivery pipe. Now on the other side, to improve the efficiency, we have attached another set of suction and delivery pipes. This is a suction pipe 2, this is delivery pipe 2, where we can get more uniform discharge. Okay. Now let us try to understand how this will work. Now in the previous single acting reciprocating pump, we have seen when the piston is moving to the back side, here we will create suction. On the other side, we don't use any kind of energy because there is no suction pipe or delivery pipe. So if water is present here, this will be, now this is a double acting reciprocating pump. We have another set of suction and delivery pipes here. When the piston is moving from left side to the right side, if water is present here, if water is there, this water can be pushed into the delivery pipe. Okay, this will produce one pulse, and then when the piston is moving from right to left, now we have created some suction, water has entered into this cylinder. Now we have water on this side, on the left side we have water. When the piston moves from right side to the left side, now again the water will be sent into the delivery pipe. Here we can produce second pulse. Now, when we have a single acting reciprocating pump which is rotating at 100 RPM, we can produce like 100 pulses. 100 pulses of water can be produced along with a gap in between each pulse. If we have 100 pulses, we have gaps like the flow of discharge, the water coming out of the reciprocating pump will not be uniform. We have gaps between them. Okay. So because we have a suction which is idle, where there is no water coming out of the reciprocating pump, and only we will get water during the compression. That means piston that is going from right to left. Okay. So in order to avoid this and to get a uniform flow, we have designed this double acting reciprocating pump, where in each stroke you will get some water. Some water will be sent into the delivery pipe. Here we can see these two delivery pipes are attached to a single pipe, where we can get the same amount of water. That means we can combinedly get a continuous flow of water. Okay. So this is what happens when we use a double acting reciprocating pump. Now, when we want to calculate the discharge of a double acting reciprocating pump, we can simply multiply the formula of a single acting pump with 2 times the single acting discharge. Okay. Discharge of a double acting is equal to 2 times the discharge of single acting pump. Okay. Because we will get more discharge, we can get more amount of water that is coming out of the reciprocating pump. Now, we'll see what are the uses of reciprocating pumps. So, the reciprocating pumps are generally used for oil drilling operations, where they can be used to drill water or oil from underground, and they can be lifted or they can be transferred to a place where they can be used. And second one is pneumatic pressure systems. In pneumatic pressure systems, where we will use compressed air, for that purpose we can use this reciprocating pumps. And then third one is light oil pumping. When we want to use light oils, that means in olden days we will use some kind of we have to pump very light weight oil. That means very thin oils. If we want to pump, that means at a small quantities, we can use this kind of reciprocating pumps, because reciprocating pumps can produce very high head, but they can produce very low volume. They cannot create large discharge. Okay. Discharge is low. That means amount of water that can be pumped with this reciprocating pump is very low. And we can get very high head. Head is high. Very high head can be generated with the help of this reciprocating pump. Okay. And again, feeding small boiler condensates can also be done with the help of reciprocating pumps. So far we have seen the working, classification, different types of reciprocating pumps, the calculation of discharge and uses of reciprocating pumps. We'll meet in the next lecture. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.